All right, looks like we're going live. And we are live, great. All right, so thanks everybody for joining. Today, this is our last meetup of the year. We're very excited. We've actually been quite busy these last couple of months from KubeCon until now, until this week. All right, so thanks everybody for joining. Oopsies. This is our last meetup. So about that feedback. But this is our last meetup of the year. Since KubeCon, we've actually been shipping a lot of announcements. We've been launching a lot of new things. We've had a bunch of new projects as well. So we wanted to take the time to actually get a meetup in at the end of the year and also spend a little more time going through these things and then have demos and opportunity for questions from everybody online. So I'm Betty. Nice to meet you. If you want to hop on video, you're more than welcome. We've got Scott Weiss, one of our engineers, our principal engineer here at Solo, and then Christian Posta, our field CTO online. We've got folks' Twitter handles here so that if you want to hit people up with questions later, you're more than welcome to. But today I will be also watching the chat. So if you want to type a question in the chat, that's fine. If you want to just unmute and ask, that's also fine. We're gonna keep this very casual. So let's go. So today we're gonna have two things. So we're gonna have Autopilot, which is a new open source project around building operators for service mesh. So Scott's gonna talk about that. And then we announced that the week of KubeCon. And then we have WebAssembly Hub, which is basically a new hub for building customizations, custom extensions for Envoy and Envoy-based products using WebAssembly. And so there's a new hub for that we announced yesterday. And so Christian's going to go through, show you the hub, show you the things you can do, and a demo. So with that, I'm going to pass the ball to these gentlemen. I think, Scott, can you just take over and share? Give that a shot.
Okay, unmute. Can I share? Should I share? Let's see. Yes, should I take over with the screen share or?
Yeah, go right ahead, and then we can just go straight to your screen to talk about Autopilot.
Okay, very cool. Thank you, Betty. Let me just share there. Everything good? They're looking good. Okay, so thank you very much. I am going to show you guys a little bit about Autopilot. Just to give some context, solo.io has been in the Envoy service mesh space for basically since its inception, which is over 2 years. We started with Kubernetes operators from the outset. Everything has been done in an operator style. So our core product Gloo is driven by CRDs, different events from Kubernetes, and has a declarative system for ensuring a desired state. So if you're familiar with those concepts, you've already kind of gotten the nitty-gritty of Kubernetes a little bit, like using CRDs. You'll understand the approach from that point of view. And then that drives all of our automation. And it hooks into our Git workflows, so we've been using GitOps for a long time. And basically, we've developed a few times in the past different internal frameworks for working with, for building these operators. Particularly, we have a lot of redundancy around service mesh, so configuring Istio virtual services, monitoring outputs from Prometheus and metrics and things like that are built into our existing operators. And what we felt like doing as basically a next step for us is with this framework to take it to the open source and really try to get some community around it in a similar way that Red Hat's done with their operator framework. And so I'm going to go through Autopilot itself. It's an SDK. It's a command line for building and deploying as a command line and a set of libraries, SDK, essentially, for building and deploying an operator. And particularly with attention to service mesh. So if you think about a regular Kubernetes operator has primitives for Kubernetes built in, but doing all the rest of the work connecting to metric stores, databases, GitOps backends, different webhooks, cloud providers. That's all work that's left to the user, implement manually using various libraries, etc. So part of the idea was to take the operator concept that Kubernetes has given us and extend it to the domain of in particular, service mesh, because we were already finding such a strong investment in that space for us, a strong need. And we anticipate the market is going there as well. We've had a lot of feedback from customers and vendors. Everybody in this ecosystem is really starting to build operators at this point. And the next stage is building operators for service mesh. So let me show you what that actually means in the context of real technology. So this is going to be done using Go today. And I'm going to show you how we can automate a simple service mesh automation use case using Autopilot. So we're going to build a canary operator, just an operator that's going to do rolling deployments for us with the traffic splitting. If you guys are familiar with the canary use case, I'm not going to dig too deep into how it works. This is more to see how you can automate your service mesh with Autopilot. So if I show you my my cluster right now, I have some GKE cluster running. And hold on, I want to just sorry about that. Let me switch.
Mute your Slack.
Yes, yeah. I'm sorry. Do not disturb. Okay, there we go. So just clean up a little bit. Sorry. Okay, so we'll see. We have Istio installed is really what we want to look at here. So I have basically all you need for this is a cluster set up just with Istio installed. That's just installed using like the basic Istio 135 that you can install on your own. And now what we're going to do is basically build an operator from scratch using Autopilot. So if you see, I have an empty directory here, empty directory. And the first thing I'm going to do is I'm going to run ap-init. And ap-init is going to create the initialization files that I need to build the rest of my project. And we'll take a quick look at what that is. So if I load my IDE here, we can see what that did was it created just a GoMod file and these two config files. And the main one I'm going to look at is the autopilot.yaml. And this specifies the structure of the project. So like I said before, Autopilot's very opinionated. It makes the trade-off of making everything easy by being more opinionated about how it gets built. So it's got an opinionated structure about how the operator is structured. And basically the idea is that you have a top-level CRD, and then you can define phases for the CRD. And Autopilot treats the CRD like a state machine. That allows us to be more opinionated about what your operator essentially does. And so in the vast majority of use cases, it may be watching a large number of things, but in the end, the output is going to be some kind of Kubernetes resource very often. Now, this is also something that's extendable in the system, and I'll get into it. But right now, we can think of Autopilot as a system that takes some inputs, depending on the given phase of your CRD, and produces some outputs. So from that, let's actually, sorry, 1 second. I'm going to update this Autopilot YAML with what we need for our canary, essentially. So what you saw was the default generated one. Now here's one that actually describes the state machine that our canary operator is going to execute. And so you see I've got a few phases here. There's an initializing, a waiting phase, an evaluating, promoting, and rollback. Essentially that means that in the initializing phase, once we receive the canary CRD, we're going to read some deployments from the cluster, and then we're going to output some deployment services and virtual services for Istio. Then we're going to have a waiting phase where we basically poll and ensure that the or we watch the deployments and virtual services. We make sure that if one of those things gets, or if the deployment gets changed, we initialize the evaluation process. This is a little bit about implementation details, but essentially we're waiting for some user feedback at this point to kick off. So this might be the result of a Git workflow. Git might push a change like update the image on my deployment, and that's going to kick off the canary process that our operator is executing. So then it goes to evaluating. Then it's going to watch metrics. So I'll actually show you how that's working. It's going to watch metrics that come from the proxies through Prometheus and use that to evaluate the status of the canary. Is the failure threshold, the percentage of requests that are succeeding, is it above the threshold we've defined? If so, eventually we'll promote. If not, we will roll back the deployment. Very standard canary workflow. The purpose of this is not really to teach about canaries, but just to understand how we can automate this using Autopilot. So I have the Autopilot YAML created. Now let's see the actual code. So I'm going to run the AP generate command. This is designed to be run and rerun as you iterate on your project and build it out, so that you can create the skeleton of the project without and only have to fill in the business logic yourself. Kind of like a serverless application, if you're familiar with that concept. So we'll see we got a bunch of stuff generated here. In the interest of time, I don't want to dig too much, but essentially we'll see we have a Docker file for our app. We have a main for it, and then a bunch of deployment manifests that were generated as well. And we can dig into those. But let's look at the main function. This is a very simple binding, and this file can be edited once it's been generated to add your own bindings in. But essentially, it injects into the library method from Autopilot called run that's going to run the opinionated manager, or the opinionated operator structure that we call a scheduler internally. And what the scheduler does is it calls the user-defined work functions. And those work functions can be found in this workers. And you'll see if you go, this is where you actually have to go and implement in your Autopilot code. So it's your responsibility only in Autopilot to edit these worker files, so this worker, etc., as well as the spec. So this is where you actually define the spec for your, the desired state, and then the status for your CRD. Everything else is generated for you. If you're familiar with these concepts from other operator frameworks, or you've worked with the Go Kubernetes before, you'll be familiar with these structs. You're only responsible for filling in the actual implementation of the spec and the status. Let's just see, just for kicks, what happens right now. So we can already build and deploy our operator. So just going to do that right now. You can use the Autopilot command line to automate this stuff, but it's all Docker and kubectl commands, so you can run this locally as well. But it's nice to have this. This can be made a part of a CI/CD pipeline, so you can actually deploy and update your operator in production using GitOps, which is a really nice flow. Okay, so right now it's deploying all my components. And I should actually be able to see, let's get our namespaces. We should see this canary operator namespace got created. We'll see our operators running. You can actually run AP logs to tail the logs from our operator and see, some bootstrap logs that have came up. And this is all stuff out of the box, right? I didn't edit a single thing on my project. This was all just setting up the Autopilot YAML and running AP generate. So let's go, and for fun, let's actually create one of these CRDs in cluster. Wait, I have to create the namespace. I'm going to create a CRD in the cluster, and what you'll see is that my controller panicked with this implement me message. Cool. So we're actually right up to the point where we're already ready to start implementing business logic. And it was this initializing worker that we hit, because that's the first phase. It's declared in the Autopilot right here, where we say initial phase true. So what I'm going to do in the interest of time is I'm going to just fill these in. I have these already written. But this is an example of what it, essentially a work function that's going to perform this sync operation and synchronize our state when it's in the initializing phase. I'm actually going to run a command here because I've pre-written these, and then we can just take a quick look at them. If you give me a second. I have it somewhere. Okay, I'm just going to paste this command here. This is going to copy, just so it doesn't look weird. This is going to copy some pre-written files I have for each worker and regenerate the deep copy types. So we can see we filled in the spec here. Here's a little bit of context on how our canary is going to work. You know, this is all user implementation details. This is up to you, what you want to define. You can use the status as a place to store state. So if you treat your system like a state machine and the workers are stateless, you can have them pass state information to each other by modifying and updating the status on the CRD. So that will finish up. And we can see we have a phase for each, a worker for each phase, and we should be able to build and deploy again. So we'll rebuild and redeploy. Now, if we launch our logs for our operator, we should be able to see, how's our canary doing? Okay, so now our canary actually got processed, and unfortunately, I didn't show you a good example because it went straight to waiting. But essentially, we can see here what got created from our canary. So you see it got put in the state waiting, observed generation, all of those boilerplate details will be handled for you by Autopilot. So you can do things like ensure that the generation, observed generation matches the real generation, that your operator is in sync. It's also really easy to run this locally from your machine. So I can literally just hit run here, hopefully. IDE will like it, and I can actually run this from the IDE, step through, and depending on how your operator is set up, if all it's doing is, you know, pushing and pulling YAML from Kubernetes, then you can actually run this locally. Right, so we're able to step right into our application here. We can maybe jump all the way into our worker. Let's say we have a waiting worker. We can jump right to our work function here and step through and see how locally how our operator is going to behave. It's hugely helpful for us at Solo to be able to do this kind of workflow. So we put it in the waiting phase, and just to watch it work, we can try to, let's get our pod and test, just make sure it's injected. So it was not injected. So we have to label it for injection so that it's actually going to be in the mesh. So I didn't need to delete everything. It's okay. We can just, one of the things that you'll see is if you delete the root CRD, all the stuff that gets created from it gets automatically garbage collected. Okay, so let's reapply that. We should see, I'm falling apart here. Okay, it's back in the waiting state. We can now apply a change. So I'm going to bump the image version on that deployment. And if I show you the pods now, we'll see that the this is going to be better. Okay, this is embarrassing. I'm sorry. This example is still in development right now, so I'm undergoing a little bit of a change. I'm sorry, I don't have a working version. I'm sure that there's something. I don't want to dig too deep right now in the process of this demo, but it's a problem with the example with Autopilot. So I hope this has demonstrated essentially the simplicity of building operators with Autopilot, how it's designed to take away so much of that boilerplate and redundancy with between projects that are not only leveraging Kubernetes, but service mesh as well, and simplify the process so that we can focus on the business business logic that lives inside the operator rather than all the piping that goes around it. Yeah, thank you so much. I'm going to pass it over back to.
Hey, Scott. Because this is, how can people, if people have, write an operator, and if they want to, can they,
Sure.
want them to contribute it back?
Yeah, if you want to, so you want to get started with Autopilot. The installation docs are right here. It's all done with a CLI, so there's nothing that needs to run server side in order for this to work. We have a tutorial that takes you through the steps really to illustrate like a few of the different features in Autopilot, as well as how to get started with your first project. We have a Git repo. It's all open source. We're encouraging developers to help us build it and to build on top of it. We're building internally in Solo. So, this is a real framework that's being used in production today. It's been informed by our processes. We want to build it with the community. We want to get feedback on this and use it to improve our own, as well as contribute what we've learned back. Docs.
If somebody builds, Scott, if someone builds an operator, one they're able to kind of just share with the community, where would they put that?
So we don't have a hub for it yet, unfortunately, but this is going to be something that if you're familiar with anyone who's our Service Mesh Hub, Service Mesh Hub IO has an area for managing service meshes that includes extensions, applications that you can build on top. And we're going to have hooks for, like you can see in Autopilot already, we create these deployment manifests, which is really a first step towards building a Helm chart, which is eventually part of our roadmap, that we can get Helm chart and a release process. Because these are all the things that we need to do, again, for our own software. This is something that's typically going to happen for most users who are building operators. So we're going to have extensions that allow you to easily plug it into whether it's a Helm chart repository or something higher level with a UI like the Service Mesh Hub.
Awesome. If folks online have any questions, we can probably take like 2 questions before we hand it over to Christian for WebAssembly Hub. Anyone? You can mute yourself or type it in the chat.
Hi, everybody. I have a question that I hope that it's relevant now to the discussion. I want to know that about the multi-mesh, solo multi-mesh support. If you have time in this meeting today, please let's talk more about the multi-mesh and single mesh support that you have on the plan.
So what type of support? Because it all depends. I mean, multi-mesh is something that we support in various ways. Like Autopilot has its own definition of what that means. Gloo has its own definition. So it's a question of what are you trying to accomplish exactly? You want to, I assume, manage multiple meshes. You want to control plane for managing that. Yeah. So
sorry, I interrupted. The first thing that I want to clarify the definition of the single mesh and multi-mesh in your terms, and then what is the roadmap of supporting multi-mesh in the new future from Solo?
So that is an excellent question, and is probably one that either it's going to be more involved, okay? And we definitely want to get the answer for you. Either we have time at the end, or we can set up a separate discussion for you, because that is core to what we're doing at the company, and I don't want to shortchange it.
Okay, sure. Thank you.
Yeah, let's spend some time talking about kind of like multi-mesh at the end. I think that's good.
Yeah, we can do that at the end.
Yeah, because we're talking about some service mesh, some tools for service mesh here, and then we can talk about that.
We can talk about how it all kind of wraps up, actually, because Autopilot and what I'm about to talk about with WebAssembly is all very related to the product that we are working on right now called Service Mesh Hub. And that's where our multi-mesh and management capabilities start to come together. So yes, I'll make sure to leave time at the end so that we can dig into that.
Cool. Thanks, Mohsen. Anyone have a question on Autopilot specifically right now? Or even random trivia for Scott? Moving tips. He is moving this weekend.
Much appreciated.
Yeah.
Just come if you've got any questions. Autopilot is still in development. We plan a lot more features coming forward soon. Multi-cluster support is currently in the works. So if you've ever needed to write an operator that's going to manage more than just this local cluster, Autopilot's going to help with that. I didn't even showcase the features of connecting to Prometheus and using that to monitor metrics from your cluster, using that as a source of data for your operator to act on. But we can save that for Slack, for future tutorials, releases, webinars. So please come check it out.
Cool. So then let's pass it over to Christian. So if you want to get in on WebAssembly Hub.
Yeah, let me share my screen. All right, you should be able to see my screen, right?
Yeah, and if there's specific topics that we talk about here, folks, that you want more information on, and something like an Autopilot, if you want to have a session on, because you have an idea for an operator and you want to talk through it a little more, just hit us up in Slack or ping us in the chat here, and then we can do a deeper dive.
Yep. Thank you, Betty. And I also want to point out at the beginning here that this topic, will probably spend 15, 20 minutes on it, but it is actually, there's a lot more to it. And we are going to do a full-length webinar in January or February. We'll announce it on WebAssembly, why it's important, how it fits in with Envoy Proxy, and what we're doing at Solo in more detail. But right now we'll just probably go a lot quicker and get to the demos. Scott showed Autopilot, which is a way of building workflows on top of Service Mesh. Now, what we're going to look at is, so if you look at that as kind of the up here above the mesh, what we're going to look at is slightly below the mesh in the data plane, what's running in the request path. And we'll bring it all together at the end when we discuss the multi-cluster stuff for Mohsen. So what WebAssembly is a binary language that can be injected into edge processes. I'm going to leave that vague for a moment. That can customize the behavior of that edge process. And the initial use case for it was in speeding up the execution of very, very CPU and resource intensive computations in the browser, wherein people would write their applications in JavaScript, but they needed a way to run things a little faster, but they needed to do it in a safe way, right? Because you don't want to inject code into a browser and go through all of the vulnerability issues that Java applets had and that JavaScript had and so forth. So we needed a safe way to do that. Now, that also applies to things outside of the browser. And in an edge application architecture, for example, you might be running a proxy at your edge for an ingress or API gateway scenario, or you might be running those proxies within your applications themselves in a service mesh scenario, and you need more fine-grained customization and control over the routing, over, let's say, transformation, over security. We work with a lot of customers that have very unique security requirements that need to stay backward compatible. And sometimes out-of-the-box solutions need some level of customization to fit nicely into these environments. And that's where WebAssembly comes in. So with WebAssembly, we can build that customization and inject it into Envoy Proxy. So that's what we're going to be talking about today. Inject it into Envoy Proxy in Envoy's request processing pipeline, so that we can customize it. Now, it's important to note that WebAssembly is a compiled target. So you're probably not going to be writing WebAssembly directly. What you would probably do is use a higher level programming language like a C++ or a Rust or TinyGo. And as more languages come on board and the garbage collection support gets better solidified in the WebAssembly community, more languages will be supported. So you're not forced to, if you want to extend Envoy, which we do at Solo and we've done for the last few years, and that's we built that as a core competency of our company, but that's not everybody's core competency. If you want to extend it, you don't have to write just C++, which is what Envoy is written in. And then if you do that, you have to compile it and link it into the Envoy binary, and now you have a bespoke Envoy binary that you now have to maintain. So WebAssembly is this, you pick the language that you want to write your extension in that you're comfortable with. You use a tool chain to compile that down into WebAssembly, and then you can safely inject that into a running Envoy proxy. Now, I do want to make the disclaimer that the Envoy, that upstream Envoy is the WebAssembly or WASM support is experimental right now, and that it is in the process of being merged upstream, and we'll get there. I would like to say shortly, but depending on how quickly the Envoy community is willing to work with it. But so let's pop over to what we're doing now to support that at Solo. We think that these extensions that people build to the data plane, to Envoy, remember Autopilot was the extension for the service mesh. Now we're down in the request path. These extensions that people build for transformation, for security, for various auditing and logging purposes, that these will either internally in an organization wish to be shared and reused, or even outside in a more of a community effort, shared and reused. And so Tuesday this week, we announced a offering called the WebAssembly Hub, or a community offering called WebAssembly Hub, that allows you to build WebAssembly modules and share them with the rest of the community, allow you to discover them and search for them. And we've also built some accompanying tooling to simplify building the WebAssembly modules specifically for Envoy. And I'll show you that in a second. That's huge, right? Having WebAssembly is awesome. Having it work in Envoy is awesome. But now the workflow and the tool chains and all the stuff that you need to connect together, that can be pretty difficult. And we've solved all of that for you. So I'll show you that in a second. But if we click on Explore here on the WebAssembly Hub, we see we have seeded a handful of extensions or modules. So in this case, we have a transformation module that you can use for transforming messages inside of Envoy. We have one that exposes more detailed metrics. If I click on this, we can see a total request count and number of rejected requests because of external auth failures and so forth. So we've added a little bit more richer metrics that would be useful for people. And then the Amazon Lambda, routing to Amazon Lambda and taking care of the handshake for that, that is just, we're a day or so away from that one coming. So that one's coming soon. And some of these other ones we have in Gloo today, but we're working through exposing those into the hub as well. So on to the more interesting developer piece, which is, okay, yes, I have this use case. I need to customize Envoy. I don't want to I don't want to become an Envoy maintenance company. I don't want to build it directly into the binary itself. I want to use WebAssembly. How do I get started? How do I do that? And we announced in concert with the WebAssembly Hub is a new project called WazMe. WazMe is a tool that helps you automate the workflow for getting started with and building and then publishing and sharing your WebAssembly modules for Envoy. So if you come here, this open source project, there's some instructions here. If you go to docs.solo.io/WebAssembly Hub, we can send this out in the notes afterward. You'll see some information on installing it and for running through what I'm about to show you, but I'll show you here live. So the first thing that we want to do is let's take a look at what we have running in our Kubernetes cluster already. We have a couple services. We have an Echo server that when you call it just returns your whatever you sent it to it. Right? So very simple. We're going to use Gloo, which is an API gateway, open source API gateway built on top of Envoy, and that supports the WebAssembly modules extension in a beta form right now. And that will start to solidify as upstream also solidifies. But I also do want to point out that you could do this directly with upstream as well. And if you look at the docs here, we see one with Gloo and one with vanilla Envoy. But I'll show you with how it works with Gloo. The API is much nicer right now. So the first thing we're going to do is we have this Echo server. If we take a look at our Gloo deployment, this is our API gateway. This is Envoy right here, the gateway proxy. What we want to do first is show that we can call this Echo server through our Envoy proxy, through Gloo. So to do that, let's just run a curl. We can see that, yep, it makes it through HTTP 200. We just get the request back that we sent in. It's an Echo request. So let's build a WebAssembly module that we will inject into Envoy to modify the behavior of Envoy as it's processing a request and a response. We're going to keep it simple. All we're going to do is on a response, so a request comes in, gets processed on a response back to the client. What we'll do is we'll add an additional header or two headers that we can show that we can customize the request. So to do that, we're going to use the tool that I just showed on GitHub called WazMe, and we're going to say WazMe init here, and actually we'll put it into a folder called filter. So let's do that. If we do ls here, we can see our new folder here, filter. So we'll go into filter, and if we do a listing here, we see that it generated a new project for us. In this case, we're going to use C++, but you could also use Rust. And like I said, more languages will be supported soon. But it's set up here, and we'll just open it up. It's set up our project. We have the filter code. So this is the C++ code that we'll look at in a second, which will then ultimately compile down into WebAssembly. But it also set up a Bazel build project so that we can use that to pull in all of the right dependencies, the mscripting tool chain that compiles C++ down into WASM, and any of the other libraries that we would need for this to be able to run successfully inside of Envoy. So that's all good. What we're going to do now is we're going to come to the code, and we're going to make a change here on the on-response headers. I don't know, hopefully y'all can see this in Zoom here. What we're going to do is we've got these new headers. What we're going to say is let's just add a new one just for this. So we'll say this is an online meetup, and we'll call this Gloo, WazMe. So these headers should be injected. These three headers, new value, online meetup, and location, should be injected in the response when we when we add this to Envoy. So that's good. Now let's do a build. Let's do a build of WazMe build. And what this is going to do is it's going to pull down a Docker image that will then run this Bazel build. So if you don't have Bazel on your computer and you don't want to deal with all that stuff, then we could very easily run it inside of Docker. Bazel will pull in all of the dependencies and so on, and build the C++ code down into WebAssembly. Now, the only issue with that, when doing it in a live demo setting, is that this could take a little while on the first build, on the first run. Bazel will pull down the whole internet, and eventually it should succeed. So we're not going to wait for that because we want to get to questions and so forth at the end. So I did put together this existing filter project. If we look inside of it, it should have the same changes that we made to the filter. If we come down here, we should see, yep, online meetup, Gloo, WazMe. Not exactly the same. All right, and this thing's still, Bazel's still running. Or let's kill this Docker. Let's kill this thing. Don't need that. All right, now we shouldn't see that stuff anymore. But sorry, coming back to our code, we have this project that had already been built, so all the Bazel stuff should be pulled down. If we do a build, not a WazMe build, we'll do a Bazel build, and we'll do, we'll build it locally here, and we'll give that, it shouldn't take as long as it otherwise would have if we were downloading the whole internet. And so now what this is going to do is, using the mscriptin toolchain, compile the C++, and then, so it'll use clang to compile the C++, and then take that and compile down into a WebAssembly module, which we can see right now it is linking, and hopefully it doesn't take too long to do that. And then once we do that, so we have Envoy running, and we will hopefully have a WebAssembly module. Now we need a way to inject that into our Envoy proxy. And the first thing we need to do with that is we need to publish it. We need to publish this module to some registry where we can then share it and allow people to pull it down and use it. And then this, there we go. Okay, so we can see that this thing was built. We should find it here in Bazel bin. We see it, filter.wasm. Now, this filter.wasm, like I said, WebAssembly is a binary format, but it also has a textual format. So if you do, or if you are interested, we can very quickly take a look at the textual format, filter.wasm. Look at it here. And what we can see is the way WebAssembly is structured is you define all of the functions that you've created in your module. You might need to import certain functionality. So WebAssembly is interesting in that it cannot by itself reach out of its VM, out of its sandbox. If you want to call functions outside of it, they need to be imported and they need to be manually put into the WebAssembly sandbox. And here's an example of that. So we're expecting these to be available in the WebAssembly VM so that we can import them and so on. Now you can see the function bodies down here. So up above was the declarations, now the function bodies here. But so you can, WebAssembly is really interesting. I highly recommend looking at it or coming to our follow-up webinars. Now, what we want to do is when you use the WazMe tool to push our new WebAssembly, here, let's let's look at this first. If we do WazMe list, we should see some of the existing modules that have been pushed to the registry. This is ultimately kind of a Docker registry or OCI compliant registry running in the background. What we're going to do is we're going to do WazMe push, and we'll say we're going to push it to WebAssembly.io under my repo, and we'll call this online test v0.1. And then what we're going to push is Bazel in filter.wasm. So we'll give that a try, cross our fingers, live demo, and it pushed. And we call this online test. So now if we do list again, we should see our online test. And we do. And that's excellent. So now we've pushed it into a registry. Now what we want to do is configure our Envoy proxy to pull that down, from the registry and load it into the proxy. So if we do, what is this? Gateway WASM. If we take a look at that, what we're going to do is we're going to configure Gloo's gateway to load the correct image, which is, it's not correct here. So we're going to have to look at that. So this is version 1 of online test. And then we'll cube apply this gateway v2 WASM. That will then prompt Envoy to inject this new WASM code that we created. And if we go here and watch, should first of all make sure that the proxy doesn't crash, because we don't want that, especially in a live demo. We see that looks to be stable, so that's good. Now the WebAssembly module should be loaded. Let's try to curl that echo service again and see whether the headers were correctly added. And if we do that, we should see indeed that in the response headers that we have our 3 new headers, new header and online meetup header and the location header. So now everything works. We like it. Let's share this. Let's share this with the community. And that's where WazMe catalog add comes into play. WazMe catalog add is going to say, all right, now you want to publish this to everyone else and make people aware of it. Let's, so we'll WebAssembly.io, and that was online test v1. Let's do that. What it's going to prompt us for some of the details that you want to include in the catalog when people come and find it. What's the name of it? Online test. Yeah, that's fine. Here's a short description. We'll go a little quicker because we're running out of time. The long description. Yeah, that's fine. Yeah. .io. Yep. url.solo.io. Again. And now it'll say, are you sure you want to publish this? And now this will kick off. We say yes. This will kick off a Git ops style workflow for creating a PR into the WebAssembly Hub's catalog. Now, if we come over here and look at this pull request, we can see now the owners of the catalog then can go through the details and decide whether to approve it or not, and then that would bring it into the catalog. So that's what we're working on with respect to WebAssembly. We think it's an important part to our story, which is how do we make service mesh simple for people to use and to operate, to make it realistic in an enterprise environment, because in many ways what's out there already is lacking in that area, and we want to build the tools to do that. And WebAssembly Hub represents, and WebAssembly stuff in general represents how we can get the customization, level of customization that we need within a API gateway, within a service mesh, to get it to run nicely and safely in your environment. Service Mesh Hub then is our management platform for directing all of these changes and coordinating configuration, managing multiple clusters, managing security across the clusters and so forth. And then when you have a service mesh in place, nicely running, you can get the value out of it, which is, how do we do canary automation? How do you do chaos experimentation? How do we do service debugging? All of these things that you need to build on top of the service mesh. And that's where Autopilot comes into play, to be able to write these extensions to the mesh. So that's all I have. I know we were going to get back to the multi-cluster question, but were there any other questions in between that?
Yeah, so if there's any other questions, unmute yourself or just pop them in the chat. Don't be shy. Nope. Okay. So Ahmed says no questions. All right. If no one has a question, then Christian, do you want to just address the multi-cluster or the multi-mesh kind of question?
Yeah. And so we are working on a project called Service Mesh Hub. Service Mesh Hub is our management, centralized management plane for running and simplifying a service mesh, irrespective of what mesh implementation you decide to use. So it could be Istio, could be Linkerd, could be App Mesh from AWS, Console from HashiCorp, and so on. Now, simplifying a mesh is in huge demand right now because they're all fairly complicated. And that's for a reason. The APIs that they expose are intended to be lower level APIs. They're not intended to be driven by developers and by humans, actually, in general. And so with Service Mesh Hub, we can simplify that by giving a more natural user experience depending on who's operating the mesh. Is it the SREs? Are the developers interacting with it? Is it the security folks? And so on. Now, operating a single mesh is, you could probably get away with doing that with enough duct tape and wire and so forth. But when you get into a non-trivial deployment of a mesh, that's going to involve multiple clusters, multiple control planes. So when you deploy the mesh, you're going to have multiple isolation zones. But you give up the most important property of the mesh, which is service identity and observability and traffic routing, if you start to fracture the deployment. So what Service Mesh Hub does is bring them together. So if you have multiple deployments of an Istio service mesh, we can unify those into a single pane of glass. If you have an Istio and then you're also going to go to AWS, and AWS App Mesh is free, so you might use that as well, and you need to bridge those two, then Service Mesh Hub can be used to do that. And I think it might be a great idea to do an online meetup at some point, where we show what we have so far with this and elicit community feedback, because right now we can do a multi-mesh flattening of the various meshes. So I think that would be a useful topic at some point. So were there specific questions that you had, Listen?
Yes. The first question is that, so you define by the Service Mesh Hub, we can install a single mesh on top of the more than one cluster. Am I right?
That's correct. Yes.
Okay. So what is your definition in your term as a single mesh? Single mesh means that all of the clusters has one control plane, separate control planes that talk to each other, or just one master pilots and everybody is a slave? No. So in our view, you will deploy the control plane components to logical isolation zones,
right? So think availability zones, right? You would have a control plane for your mesh in various, let's say 3 availability zones, because if one goes down, you don't want to lose the capabilities in the other available. That's the whole point for the isolation, right? And so what Service Mesh Hub then does is it drives those 3 control planes, and it configures them. So for example, if we were talking about Istio, to achieve a unified flattening of the mesh so that services in one side of the mesh can talk to the other, and maybe they're in different availability zones, you need some configuration, or a lot of configuration that goes into place to make that happen. And so what Service Mesh Hub does is it simplifies that by automatically configuring the service entries, the virtual services, any of the root CAs and intermediate CAs and so forth, to be able to establish identity, single domain of identity across those 3 different availability zones, so that when the services are running and they're interacting with each other, they're talking to each other as though it's just one big single mesh. But in reality, the deployment is you might have a Kubernetes cluster in availability zone 1 with an Istio control plane there, as well as in the other availability zones.
So it means every cluster has its own pilots?
Yes, yes.
And you define is as a single mesh, not multiple mesh that connected to each other.
They would be defined in our view as a group of meshes, actually, but a single group, one group. And a group means one logical mesh, yes.
Okay, I appreciate if you plan for a meetup for these topics, because it's hot topics, and I think that we can contribute a lot on these topics.
Yeah, we would love to have you back, and we would love to show you. We can go into more detail about that. We can show you some demos. We can dive in and break the demos, so we can do any of that.
Okay, I appreciate. Thank you.
Yeah.
Cool. Any other questions? I think we have time for one more, if folks can.
If nobody have question, I can continue.
Mohsen, I think we should do a whole thing just around this whole like multi-mesh, like all the possible scenarios. Yeah.
I'm kidding.
You've given me an idea for a whole other discussion topic, just to dig into like, how do you define it? What are the different ways it could be set up, permutations, and how would you configure and operate it?
Pros and cons, why you would favor one deployment architecture versus the other. And I think that would be great.
Yeah, the things is that honestly, it's my understanding, maybe I'm wrong, but there is not a single definition for single mesh versus multi-mesh. Everybody define different things. The first thing that how we define a single mesh versus multiple mesh, okay? And then another thing that is a mesh federation, and then we can dig into the what is the best tools to unify the.
Can I jump in for a second? Because I think that there's a very clear technical definition of, at least for now, the way Envoy is set up, because Envoy is always receiving its config from exactly one control plane today. That might change in the future, but if you have multiple control planes, I think that that's definitely a logical boundary between a service mesh instance or a service mesh segmentation. You may consider it, organizationally speaking, to be all one big mesh, but you still need some tooling on top of the control plane, like on top of Pilot, et cetera, itself, in order to orchestrate that and join them as a single mesh. And I think that's what Solo is referring to. It doesn't really matter if you're talking about whether they're in multiple clusters or in a single cluster, but we've been seeing lots of use cases that call for, sometimes Kubernetes as a service, et cetera, where you have basically a different control plane for each tenant, or you have multiple control planes that need to be managed across environments. And you need a control plane for that, essentially, because you don't want to be managing, whether it's in a single cluster or multiple clusters, it becomes the scale of managing all that configuration just becomes immense and really, really difficult to do unless you have some sort of controller built on top of it.
I wanted to give, I saw William raise his hand, so I wanted to give him an opportunity to ask his question.
I actually may have already answered my question.
Okay.
What was the question?
Okay, so I kind of feel maybe stupid asking it because it's a little bit of more of a novice question. So I'm kind of new to your everything you guys are working on. I'm coming at this from sort of the like the Node.js world, and I sort of in the last couple of weeks really stumbled upon all the capabilities of WebAssembly. And I was mostly curious, I guess I think I answered it, but I'll go ahead and ask it anyway, for sake of looking like a noob. I'm interested in orchestrating a cluster of WebAssembly containers by themselves. Like that's something I could totally do, right?
So when you say WebAssembly containers by themselves, what does that mean?
Yeah, so I guess let's say hypothetically I had like I don't know, a couple services running that are Rust. They're compiled into WebAssembly containers, yeah, I'm mostly interested in like the process of creating a service mesh with those, and then orchestrating I guess those.
Yeah. So let me take a stab at it.
Sure.
So so this is specifically WebAssembly running inside of Envoy Proxy. Right?
Yeah.
So if it's WebAssembly running on its own, that's kind of outside of what we're looking at. But so from a control plane, we'll just be generic right now. From a control plane, you might want to change the behavior of Envoy when it runs at runtime and in the request path. And from this control plane, what you should be able to do is say, you know what, I need SOAP to REST transformation. Maybe that's not a good example for you, but I need SOAP to REST transformation on these calls over here. Go do that control plane. The control plane says, okay, well, I know I have a SOAP to REST WebAssembly module here, and I can go deploy it to the envoys running in this subset over here, and that I need to then configure those to behave a certain way, right? So we need to be able to do that from a control plane, independent of what service mesh is actually being run, right? So maybe you're using Istio, and maybe Istio doesn't have a really good way to do that. Maybe they do, and then we just end up, building a nicer interface to be able to do that. But at some point, Envoy is the underlying capability, and that's where we have our core competency. And so whether that's through the service mesh or around the service mesh to be able to do this, that is a goal with the Service Mesh Hub product.
Cool.
Does that answer?
Yes.
Okay.
Yes. Thank you.
Yep.
Cool. Thanks everybody for joining. And actually staying on because we kind of went over the hour, so really appreciate it. This is recorded. We'll send it out along with some links to learn more. And if you have follow-on questions, just hop into slack.solo.io. That's our community Slack channel, so we can keep the discussion going on in there. And then there's also, you can kind of DM us respectively on Twitter or go to the Solo channel. Until next time, thanks everyone.
Yep, thank you all for joining.
Bye.
Have a good one.
You too.
Bye.